Hello and welcome back to the Electronics and CNS Senior Projects presentations today. The first group we have up is MyDorm. Um, my name is Steve Johnson. I'm actually the instructor for Senior Projects, and it has been a pleasure this year working with all of these students, seeing all these great projects actually work. So I hope you were able to see their poster board session earlier. If not, we'll have that up on YouTube so that you can refresh and see that. So don't miss that. Um, right now, I'm going to turn it over to my dorm so that they can do their presentation.
All right, thank you. So this is our senior project, Ferris State MyDorm. And so this is based around home automation and the Internet of Things. So basically that's presentation is going to flow. I'm going to start out and kind of introduce you to the project. We're going to go into some of the more specifics. Abdul and Elizabeth are going to talk about how the electronics function. We're going to bounce back to me for Amazon Web Services, the website, and Amazon Alexa. And then we're going to close out with Jeffrey talking about the electronic control systems. So basically what our system does, it allows students to control and monitor their room in real time. So we've got the window, a door lock, a heater, and a light switch with a dimmer switch. So from the website or Alexa, they'll be able to change all those different features. You'll be able to unlock your door, open your window to a certain percentage and things like that, as well as see where those things are at as far as if you came to the website fresh and wanted to know, what temperature is my room, something like that. And we designed it. You're going to see a picture of it in the future here. It's going to look like the MyFSU webpage. Any Ferris student is already familiar with that. It's the same place we go to view our grades or register for classes or anything like that. So we're going to, like I said, we're going to dive into the specifics of how it works. But at a high level, we're using Amazon Web Services cloud infrastructure to send and receive messages. So from the website or from Alexa, it's going to send a message, and that's going to be relayed through AWS. And the Raspberry Pi microcomputers are going to be listening for those messages, taking actions through their code based on what the message has. And based on what the code tells the electronics to do, the electronics are going to take certain actions. So I'm going to hand this over to Elizabeth to talk a little bit more about those electronics.
Thank you. The mouse. Thank you. All right. So as Jeremiah mentioned, Abdul and I had the opportunity to work on the electronics portion of our senior project, which once again consisted of the window motor, the window sensor, the light, the temperature sensor, the heater, and the door lock. So my intention is to give you guys more of an overview of how we connected these components to the Raspberry Pis, as well as a few specs. So first we have the LED matrix, which served as our room light. It's a matrix that consists of 119 tiny LED bulbs that can not only be turned on and off, but also have the ability to have their brightness controlled using PWM, which is pulse width modulation. We also incorporated a push button in the bedroom itself so that the user could manually adjust the light as opposed to just using the web interface. And connecting the board to the Raspberry Pi itself was quite elementary due to the fact that it was designed to fit the Raspberry Pi. So all that we really need to do was solder it to the header of the Raspberry Pi and then program it. Next, we have our heater and temperature sensor. So we didn't really get to see it working during our presentation since it's constantly running in the background. And once it does need to get turned on, we will have the heater turn on. It's a little light that turns on, but I'll give you more details of how it works. So it's a system that is composed of 4 main components: the light bulb, which is our heater, the relay module, which is an electromagnetic switch, the Raspberry Pi itself, and the temperature sensor. So the way that the system works together is the temperature sensor is continuously running and recording a value of your temperature in your room. And there is a set point value that is set by the user, which is a thermostat value. So the two values are compared together by the program. And if the program realizes that, for example, you set your room to 76 degrees and the temperature sensor reads your room at 74 degrees, the program will then send a signal from the Raspberry Pi to the relay module, energizing the electromagnetic coil, closing the contacts of the relay, closing the circuit of the light bulb, and energizing our heater. So the heater will stay on as the temperature sensor continues to read the room's temperature, and once it reads the temperature at or above the set value that the user set, it will then turn the system off, and it will continue to run in the background and turn on and off and keeping your room at a steady temperature. Next, we have a window sensor. So the window sensor was important to include due to the fact that if we wanted to operate a window, we need to know the position of the window itself so that we could adjust the distance of the window accordingly. So for our window sensor, we used an ultrasonic sensor, which the way that it operates is it emits an ultrasonic pulse that will travel a distance until it hits an object. And then once it hits an object, it will echo back to the sensor. And this echo value, I'm going to go to the next slide. Echo value is time. It's recorded and multiplied by the speed of sound and divided by 2 since we only want one of the distances traveled. And this will then give us the actual distance traveled. We can then convert this distance that we calculated into a measurement, a unit of measurement that we will use to adjust our window. It's also important to note that devices such as the ultrasonic sensor operate at 5 volts, and the Raspberry Pi's GPIO pins only accept a tolerance of 3.3 volts. So devices that were running at a higher voltage required voltage dividers on the pins so that we wouldn't fry anything. I'll now hand it off to Abdul to give you more details on how we operated the motor of the window.
Also, we use a stepper motor to open and close the window. Stepper motor is a brushless DC motor that rotates in steps. This is very useful because it can be precisely positioned without any feedback sensor. Driving mode. In our program, there are several different ways to drive the stepper motors. In our program, we use half step drive mode to increase the resolution of the stepper motor. This mode is a combination between wave drive mode and full drive mode. So that's this mode is had one active coil followed by 2 active coils, and again 1 active coil followed by 2 active coils. That means we can get double the resolution with the same construction. So the rotor will make a full cycle in 8 steps instead of 4 steps in the wave drive and full drive mode. So in this truth table, you can see the 8 steps that do 1 cycles, and in the other side you can see how the coil acts in each steps. To open or close the window, we need to throw these steps 825 times, which is 6,600 steps. And here you can see how we connect the BI to the drive chips and the motors. And also we add a 9 voltage power supply to support the motor when it's moving. Also, for the door, we use solenoid motors to lock and unlock the door. The solenoid being connected to the relay, and the relay being connected to the BI. So when we send a high signal to the relay, it will be switched from normal open to normal close. So when the circuit is closed, the solenoid motor will unlock the door, and when we send a low signal, so it's gonna be open the circuit to lock the door. Also, we add another option to unlock the door by using a card reader. So when you swipe your student ID, it's gonna be unlock the door. Jeremiah will explain that more.
Thank you, Abdul. So, like he said, one of the options that we have to unlock our door is the card swipe reader. But additionally, and for every other control as well, we have our website here. So as you can see, we have a bunch of different controls for everything. We've got buttons and sliders and even a text input box over there, all with different functions based on what they're controlling. You can see that we have the lights, the door, the window, and the heater in order there. So all of these buttons take different actions, but generally they all send messages using the MQTT protocol. So that's kind of a common format that our Raspberry Pis are going to understand. And so when you click any of those buttons, that's the kind of message that they send. As far as the website itself is concerned, it's stored in an Amazon S3 bucket, which is just a way to say that it's stored in Amazon's cloud server somewhere else, so we don't have to own the server. The code is stored in a GitHub repository that we own, and then using a service called AWS Amplify, Amplify will take all of that code and build it into a full-fledged website. So all of those code files are actually JavaScript language files in the React framework. There are 7 component files that you can see on the right side, those little black fancy icons, and they all come together into one master file. If you remember the little white boxes, like the box that contained all of the features for the light, that's its own component. Each one of those white boxes come together to make up the file. We also, you can see the styling. Any Ferris student is going to recognize that that was tailored basically to look almost exactly like the MyFSU webpage that we use for everything else. So we used a CSS file to kind of give it that inspiration. There's a lot of strong authentication going on in the background as well. So we wanted to make sure that only the student who lives in that dorm room is able to control the features of that dorm. You wouldn't want somebody else able to unlock your door, for example. So we used more Amazon Web Services features called Cognito and Identity and Access Management. So those assign a unique ID to each user to make sure that only that person is able to access those features. And one last thing about this that we really wanted to stress as we were figuring out how we wanted it to look was that we wanted it to be available for anywhere. You know, it wouldn't make sense to only be able to control your dorm room if you were currently on campus. That kind of defeats the whole purpose. So we have this available worldwide through an Amazon Route 53 domain. We have a website that anybody could go hit at any time. So if you were relaxing on the beach in Jamaica and were really worried that you left your window open during that thunderstorm, you could pull up our website, make sure, okay, yes, my window is fully closed, and go back to relaxing. So each aspect, the heater, the door, and everything else, they all have their own topic. Amazon calls these things for the Internet of Things, but that's a really confusing name. So we've been calling them topics. Each topic has its own security policy as another added layer to make sure that only the person that should be controlling things is. And they also have their own unique certificates. And so those certificates are placed on the Raspberry Pis. And the Raspberry Pis then send their message along with the certificate, and that certificate is authenticated against Amazon's root certificate authority to make sure that that device is basically authorized to send the message so that nobody else could go run a script on their own Raspberry Pi and get into our system. These messages that I keep talking about kind of look like what you can see there. They'll say something like door unlocked or heater 75. And as those messages come into the Raspberry Pi, they'll understand what to do with them based on the code. Another input option that we have is an Amazon Alexa device. And so it listens for the invocation of Ferris State MyDorm. So when you say those words, Alexa listens to what comes next, whether it's unlock my door or open my window to 75%. And then that input is then fed through an AWS Lambda JavaScript function. And that function takes that input and takes actions based on what it is that you said in the message. So kind of looking at it all together, we have the website in the top left here, sending messages to the topics. We also have Alexa sending those same messages up to the topics. And on the right side, we have the Raspberry Pis listening to the messages sent to the topics and taking actions on their respective electrical controls. So for a little bit more about the logic behind those control systems, I'm going to hand it over to Jeff.
So for our control system platform, we decided to go with the Raspberry Pi Zero Ws for 2 reasons: their Wi-Fi capabilities and the simplicity of their GPIO input-output system. We decided to use a standardized naming scheme and image for consistency and debugging. In aggregate, these Raspberry Pi devices control 4 subsystems: the window, heater, door, and light. Within these subsystems, they have their own unique control processes that come together to form the subsystem itself. For our software platform, we decided to go with Python 3.8 for 2 reasons. Its compatibility with AWS, as Amazon offers us some SDKs and libraries that we can use to connect to Amazon IoT infrastructure and communicate with Amazon. The electronics was the second reason. A lot of the devices we're using for MyDorm are custom devices, so to be able to communicate with them, we needed custom libraries, and Python has a plethora of such libraries available. At a software level, for our subsystem, the hierarchy was generally the same. We had a main script running infinitely that would call the action and sensor scripts as needed. The action script would perform an action when called by the main script, and then the sensor script would return a sensor value when called. The main script was charged with connecting to Amazon, so it would establish a connection. From there, the following was possible. So it would handle subscribes, So if somebody made a change on the website, a subscription message, as we call it, message would come into the main script and it would have to digest it. Publishing was the inverse of this. So if we had to push an update to the website, or publish rather, we had to have a process for handling that as well. So to outline that, I have a couple of processes over here laid out for you. So say an incoming message comes in, it's first checked to see if it was a message just published to the website. If it wasn't, then we extract the data from that message and then load it into a local variable, and then it's set and ready to go. For publishing, we load whatever data we want into a variable, pair it with the topic we want to send it to, and then we push it to the Amazon website, and from there the website handles it. So another important part of this main script is its infinite loop. And this is what allows it to run an infinite amount of time and listen for messages for however long you want it to. So this was charged with updating the website periodically, about every 5 seconds, updating a local last message variable, which was the last message pushed to the website, and then calling an action function as needed. So if there was a change that needed to be enacted upon the electronics, it would call this function whenever. And then like all the scripts in the MyDorm system, it can be killed with a keyboard interrupt. Just makes debugging and troubleshooting a lot easier. So continuing on about the infinite loop, there were variations with scripts that were using a sensor as opposed to those who weren't. So those who weren't using a sensor executed either procedural or conditional logic. With procedural execution, it would execute a fixed instruction set and path, meaning it had a fixed set of instructions that would just execute an infinite number of times, like the door swipe. It's just swiping a door, it would listen for it, execute its body, and then go back to listening. Whereas with conditional execution, it would its execution path was based on a change from a certain source. So if there's a change on the website, it would receive a message and decide what to do with it from there. Or conversely, or adversely, if there's a change physically, it would digest that change and decide whether to push an update to the website or not. And you can kind of see the logic outlined here. The action and sensor scripts were nearly identical. They first started off by initializing their GPIO or their device-specific IO, such as the light. The light was using a very specific IO that we had to have libraries for. Both scripts had one central function that was identically named to their parent file. As you can see here, the action sensor function is below the main scripts. Their body was executed once. It's in this body where they modify their IO or they talk with it. It can be killed with a keyboard interrupt. And the differences come between the two and how they basically function. So the action function takes a parameter and it uses that parameter to manipulate the IO. So with the window, it's more like a distance value. It would take that distance value and decide how far to open up the window. And obviously, since it's only performing an action, it doesn't need to return anything. The sensor function didn't have a parameter. It just retrieved the sensor value, whether it was the window sensor or the temp sensor, and then it would return it to the main script as a local variable we called sensor val. And you can kind of see both processes outlined here. So that is all we have for you today. We'll open the floor now to questions.
In the event of an emergency, how do you guys handle if there were a fire in the dorms or maybe a weather related emergency?
Yeah. So he was asking if there was some sort of emergency event, such as like a fire or what was the other one? Like a weather related event or anything like that. We've designed it to be pretty robust in terms of how it responds to things. A lot of our real world controls, like the window sensor and everything else that we built into it, was designed to work physically as well as from the website. So if there is something that happens to take out the power or anything like that, you're going to be able to get into your door because there's going to be a key on the door, of course, or your window is going to be able to manually push back and forth. It's not just a digital control.
How do you prevent your website from being hacked?
So a lot of the security controls behind this. Oh yeah, thank you. So the question was how we avoid the website from being hacked. And a lot of that is a lot of why we decided to go with AWS as our platform. So I mentioned that Amplify is what we chose to build off of our code repository. A lot of what the security features happen in the background, Amazon is hosting that site. So a lot of their security is running behind the scenes to make sure that it's running through their firewall and all of their conditional logic to make sure only the right people are getting in. And as far as like room specific things go, I talked about a little bit about how Cognito has the unique identities. So you can see that I'm logged in up on the screen there in the top right. If somebody else tried to log in, obviously they would need a login. But even if they were able to log in, they would only be able to access the things that are associated with their information.
All right. So first of all, good job, guys. I really enjoyed your talk. I've got a laundry list of questions. I don't know how much time do we have here. Okay, 5 minutes. Oh, no problem then. This is great. Okay. So my first question is, what happens if somebody puts an appendage through the window as it's closing?
So the question was, what happens if somebody puts an appendage through the window as it's being closed? We don't have a functionality at the moment to protect against that. However, we did think about it. We just didn't have enough time to implement a solution. Given more time, of course, a lot of things like that would be implemented. We were thinking something like a safety button. A safety button. So, you know, right next to the window. So if somebody's arm is caught in there, they can just hit it, or because yeah.
Okay. Thank you. My next question is, I didn't really hear a cost about this. So first of all, just, how much money are you paying the almighty Jeff Bezos for this service?
So thankfully, Jeff Bezos was he was asking about the cost and how much everything behind the scenes is. Jeff Bezos was pretty nice about a lot of this. So the message subscriptions, we send a lot of messages back and forth. Like Jeff said, this website is constantly getting updated every 5 seconds, so you have a fresh value. We actually get up to 250,000 messages for free each month. I think total cost as far as everything AWS goes was only about $13, and 12 of that came from paying for the domain. So a lot of this, even hosting the website and their services and everything, because we're not getting ridiculously in depth with it and hosting a bunch of things, they have a lot of free services that are supposed to kind of lure you in a little bit.
Okay, good. And what about total cost of your project?
Yeah. So a lot of our cost comes from the Raspberry Pis. Each little Raspberry Pi is about $10, but with the kit that we were going to include GPIO headers, power adapters, everything like that, they were about 30 total, right? So between that and all the motors and everything that you guys had purchased and the sensors, I think our total is around $350 to $400.
And this one's probably directed toward Elizabeth, because you talked about this. So you used a bang bang controller for your heater, right? Just a simple relay to turn on the heat and turn it off. So my question is, did you consider maybe using some sort of proportional or modulated control so that it's not just full on, full off? And can you do that with this thing?
I mean, not necessarily. So the question was, did we consider using anything other than the relay? Is that correct? Am I understanding correctly?
Yes, what I meant was, right now you have either the heat fully on or fully off,
Oh,
and
I
I'm
see.
wondering if
Yeah.
there's a way to modulate that so it can go 0 to
Yeah.
100%.
So there are abilities and ways to operate your temperature and have your temperature controlled, as opposed to having it just on and off, having it be gradual. But for us, it seemed more it made more sense just to have it running continuously and have it turn on and off and just keeping it at a steady temperature, since it was such a small difference in the room temperature in our design, at least, that it wasn't turning on as often as, I mean, you saw during our poster board presentations, it didn't even turn on at all. So it's not something that's continuously turning on, but I mean, in the real life world, we would probably implement something that's more gradual and makes more sense in the real life application.
I promised Jeff I would ask this question during his presentation here. But so with how the display's set up and everything, I'm assuming that your ultrasonic sensor is outside. Why was an ultrasonic sensor chosen?
The question was, why was an ultrasonic sensor chosen? Budget. We chose it for budget. And it was also our first choice. So it was budget, our first choice, and it was very compatible with Python. It only took a couple lines of code, some libraries to get it up and running.
Do you think there could have been better options?
Most certainly, yes. There were infrared sensors out there that we had considered. Granted, we considered them too late. It was a bit too late before we start, because we had problems with interference with the ultrasonic sensor because it uses sound, right? So once in a while, it would open up the window on its own or something like that. So, but by the time we got testing it, it was too late to implement something else. So, anybody else?
Yes, there is always one more question. Okay. As usual, I actually will ask the last question of each group, and um, this project, in a sense, or senior projects, is actually two courses that the students take. It actually encompasses a project management course that they take, and then senior projects is where they put all that wonderful paperwork and all that good stuff to actual use. Okay, so the projects you actually see here today, there's a lot more involved behind the scenes. There's a lot of status reports and stuff they do, a lot of paperwork, and um, through that, I'm going to say, at the beginning of this, you had to do a proposal that basically stated what your scope of this project was. But a key thing of project management is change management. And could you tell us how you implemented change management through this project?
Yeah, so we kind of had a general picture of how things were going to look, but of course this wasn't going to be our end product. There was plenty of changes going on. So, we're a very tight-knit group. We were always talking in constant communication to make sure, maybe we want to switch to this sensor, or maybe we want this added feature on the website. And so we kind of had little different specialties. Elizabeth and Abdul, they're really good with electronics. Jeff and I are the CNS program, they're the Triple ET program. So I was kind of the cloud guy in the background, and Jeff was the one writing all the code for the control systems. And so anytime that we thought about a certain change, we looked at, okay, who is that really going to impact the most? And so if I wanted to change something and like I didn't like the sensor we were working with, I'd run to these two. Or if we had a certain logic change, I'd talk to Jeff and say, is this going to be compatible with your code? So it was really kind of looking at what do we want to do? I want to go talk to the person that's most knowledgeable about that and see how it's going to impact their system.
Okay, very, very nice. Very nice presentation. We're going to get ready for the next presentation. So we'll actually exit out here and then start another live stream. Um, on the channel, though, if you click on the About, there are two links available. One of them actually can go to the program that shows all the bios of all the students and the purpose of their project. There is also a link for voting for best project. So make sure to check those out.